Weight Shift Control 6.1 Flight Maneuvers. In flying a weight shift control aircraft, it's a different ballgame compared to driving a car or operating traditional airplane controls. Instead of a stick or yoke, the pilot uses a control bar, an integral part of the wing structure, allowing lateral and longitudinal rotation about the hangpoint. It's unique. There are no movable control surfaces with push or pull rods or cables. You get a distinct feel in weight shift control. The pilot senses forces on the wing through the control bar, which is part of the wing structure and lacks mechanical advantage. Despite the different feel, the basic flight maneuvers are quite similar, requiring precision practice to develop an intuitive understanding of the aircraft. Mastering the 4 fundamental flight maneuvers, straight and level flight, turns, climbs, and descents, forms the foundation for precision flying. Understanding the effects and use of controls is crucial. Control movements are viewed in relation to the pilot, considering the pilot as the center of movement. For roll control, moving the control bar sideways lowers the wing on the side of the pilot's movement. Pitch control involves pushing or pulling on the control bar, influencing the aircraft's nose position relative to the pilot. It's essential to think of controls in relation to the pilot, not in terms of up or down, with respect to the Earth. The control bar and throttle together influence pitch in relation to the Earth's horizon. Feeling the aircraft is characterized by live pressure on the controls during flight, with controls naturally staying in a neutral position if trimmed properly. Pilots need to exert force against this live pressure for maneuvering. The amount of control input matters less than applying sufficient pressure to achieve the desired result. Holding the controls lightly is crucial for developing a sense of feel, avoiding the common mistake of tightly gripping the bar, which hinders the development of this crucial aspect of aircraft control. Flying a weight shift control aircraft differs significantly from driving a car or operating traditional aircraft controls. Weight shift control pilots manipulate the control bar, a structural component of the wing, connected to the carriage, allowing the wing to rotate freely laterally and longitudinally. Unlike conventional aircraft, there are no movable control surfaces actuated by separate control actuators. The weight shift control pilot experiences forces on the wing through the control bar, offering a distinct feel compared to other aircraft. Developing a precise understanding of basic flight maneuvers is crucial, focusing on straight and level flight, turns, climbs, and descents. Practicing these fundamentals with precision builds the pilot's familiarity with the aircraft's feel, allowing them to concentrate on the flying mission rather than mechanical movements. The flight basics serve as a foundation for more advanced maneuvers, such as takeoffs, landings, and emergency procedures, covered in subsequent. In understanding the effects and use of controls, pilots should consider themselves the center of movement for the aircraft. The control inputs are in relation to the pilot, regardless of the Earth's orientation. Sideways pressure on the control bar lowers the wing on the side the pressure is applied, demonstrating roll control. Pushing or pulling on the control bar affects pitch, either raising or lowering the nose, while throttle adjustments at a constant trim speed impact pitch in relation to the Earth's horizon. The feel of the aircraft is an essential aspect of weight shift control flying. The controls have a natural live pressure during flight, remaining in a neutral position if the aircraft is correctly trimmed. Pilots should exert force against this live pressure or resistance, avoiding tightly gripping the controls to promote the development of a sensitive touch. The ability to sense flight conditions, often referred to as the feel of the aircraft, involves not only touch but also sound. Sounds generated during flight, such as air rushing past the flight deck, provide additional cues to the pilot. Developing a keen sense of kinesthesia, which involves sensing changes in direction or speed, is crucial for pilots. Kinesthesia can warn pilots of alterations in speed or the beginning of settling or mushing. Attitude flying, centered around visually establishing the aircraft's attitude with respect to the natural horizon, is essential. Attitude encompasses pitch and bank attitudes, influencing control components like bank control, pitch control, and power control. Mastering attitude flying and developing a keen feel for the aircraft contribute to a pilot's proficiency and safety during flight. Mastering straight and level flying is paramount in developing fundamental flying skills. This foundational maneuver forms the basis for all other flight maneuvers, making it essential for pilots to establish correct habits in straight and level flight. Insufficient proficiency in straight and level flight can often be the root cause of a pilot's overall subpar flying abilities. Learning to control the aircraft in level flight involves exerting control forces just enough to achieve the desired outcome, while associating control bar movement with pitch and roll responses. Straight and level flight entails maintaining a constant heading and altitude, requiring immediate and measured corrections for unintentional deviations. Pilots use a reference point on the aircraft, such as the front tube, to fix the relationship between the aircraft's position and a point on the horizon. This reference point depends on the pilot's sitting position, height, and manner of sitting. Achieving mastery in calm air conditions is crucial, where control movements determine actual movement through the air with minimal impact on altitude and direction. Setting a trim speed is essential, adjusting the throttle to maintain level flight without climbing or descending. The reference point on the aircraft helps pilots maintain a constant pitch attitude relative to the horizon. Practice in moving air or minor turbulence requires additional pilot input to sustain constant altitude. Understanding the effect of updrafts and downdrafts on pitch control allows pilots to make necessary adjustments to counteract these disturbances. Pilots can use the front tube as a reference to align perpendicular with the horizon and keep the wings level. Any slight banking of the wings results in a turn, emphasizing the need to correct promptly for small deviations. Straight and level flight demands minimal control pressures when the aircraft is properly trimmed and the air is smooth. Recognizing when corrections are necessary and responding with measured inputs, avoiding unnecessary control movement, is crucial for proficiency in straight and level flying. Common errors in straight and level flight include using improper reference points, forgetting selected reference point locations, excessive control grip leading to overcontrol and lack of feel, improper scanning, fixation on specific reference points, unnecessary control inputs, and inadequate attention to sensory inputs for developing a feel for the aircraft. It is essential for pilots to focus on building a precise understanding of straight and level flight to enhance their overall flying abilities.